Okay. Okay. Bismillahirrahmanirrahim. This is a presentation that introduces the concept of big data, challenges, and new trends. It's not a technical seminar. It's just to explore what big data is, the new trends in big data, where research is currently in big data. You can imagine nowadays what happens in the web every minute. In every 60 seconds, in every minute, there are a huge amount of data that goes in the web. For example, you can see more than 1,500 blog posts. We have more than 25 plus hours total videos every 1 second that goes or uploaded to YouTube, for example. More than 600 new videos. Okay? There are, for example, can you see the image? Is it clear for you? More than 12,000 new ads posted in the web every 60 seconds. So you can imagine how much data is uploaded every minute in the web. And all this huge amount of data makes what we call big data. So big data includes a lot of information. It includes unstructured text, like emails, speeches, reports, social media updates, web pages, etc. It also includes commerce data, credit card information, real estate transactions. It includes geographic location information, health information, biological sciences, satellite imagery. A huge amount of data, different types, different structures are currently available. More than 90% of all data ever created was created last year. This also gives you indication about the velocity, the speed of introducing new data worldwide. So, what big data is about? What is big data? What do you think big data is? I don't like just to speak, I'd like to make some conversations. So, big data is about what? What is it? Big data is the data that is huge in its scale, in its distribution, in its diversity, okay, in its timelines. This forms the big data. For example, Google in 1998 has indexed more than 1 million web pages. In 2 years, in 2000, the number increased to 1 billion. In 2008, it's more than 1 trillion. And for sure, in 2014, it's much more. So, data is expanding very rapidly. You can see this is a relative image that shows how the data, the size of the data in 2009, 10, and the expected size of data in 2020, which is measured in zettabytes. A huge amount of data is going on the web worldwide. Not only in the web, in any media. Things are expected to go more and more and become what we call data explosion, more and more, when the Internet of Things become more and more mature. Have you heard about Internet of Things? Everything nowadays, everything available any device, vehicles, refrigerators, all devices you have at home, at work, they all will be connected to the net. And you can imagine the amount of data that will be available. So data is expected to be increased more and more. The term big data, I tried to use the Google Ngram viewer to know when the term big data used the first time. It was astonishing for me to know that the term big data is first used in the 30s. And when I tried to explore what was the issue or the topic in 30s where the concept of big data introduced, it was in the United States where a person called London tried to, he participated as a candidate in the elections, and people want to know, is it possible for him to success? Okay? And it has been discussed in an article in a journal or magazine in the United States called the Digest. Okay, so the term was introduced very early in the 30s. Then you can see here that this is 1960. In the 50s, the term big data is started to appear or used more and more, basically in statistics. So in the 30s and 50s, the statisticians started using the term of big data. Okay? When they started weighting, probability models, data fusion, time series analysis, and so on. So the term is not totally new, but nowadays it's used more and more as we can see the data extensively available through the different technologies, devices we have nowadays. Big data and the universe. There's a kind of similarity in the concept between the universe and big data. Okay? Those people who are studying the universe, they know that while they are collecting data now to be analyzed, or while they are analyzing the current information they have about the universe at that moment is expanding. The same thing regarding big data. When you use big data to make analysis, you must be sure that the data that you are using in this minute, in the next minute, there are much more data than you are using right now. Okay? And this is one of the issues that we will talk later on. The key characteristics of big data, we have what we call the big V's, the big 3 V's for big data. What big data is mainly talking about, or the main issues, the main characteristics that big data is concerned or about. First of all, the volume. Data volume is very, very, very big. It has been doubled for more than 44 times from 29 to 2020 as expected. So the volume of the data is very huge. The variety of data, we have different complex structures, data types for the data. Unstructured data, what do you mean by unstructured data? Any data other than what the traditional types of data we know, the databases, for example. This is structured records. Okay? But unstructured data, all other types of data that we talked about. Emails, videos, speeches, movies, chats, data. All these data are unstructured. Yes, any type of data. The unstructured data forms 80 to 90% of the data that exists nowadays. This is a huge amount. And this also introduces some challenges in how to manage or deal with this type of data. We used to use traditional types of data. And the other V is the velocity. The velocity or speed. Data are expanding rapidly. Okay? So these are the three main characteristics of big data. Now, some other people's added two more V's to big data. The variability of the data and the value. There's L here. The value of the data. Variability, okay? This state or validity of data in relation to the time that is used in. The value of the data for business, for example, it's important to know the value. Is that type of data valuable for the company or not? Not all the data are valuable for my company. So the value is another dimension for big data that is interested for companies, okay? For businesses. Some other people added another dimension to big data as a main characteristic of big data, which is the visualization. At the end, you need to visualize your findings, your results. So visualization is another main characteristic of big data. So now totally we have 6 characteristics of big data. Big data analytics. Big data analytics is not only about analyzing or managing the data. It's much more than that. It's about asking new questions, formulating new hypotheses, explorations and discovery of data. Making data-driven decisions. Nowadays, all businesses, successful businesses, are making decisions based on data. The use of new analytics techniques either apply it to new data sets or apply it to existing data that has been formed or put in new forms. Data mining and big data. We used to talk about data mining. We have data mining is much mature than big data. We have different courses taught in data mining. So, what data mining and big data are? In data mining, what we do? First,
We cannot look for specific pattern or.
Perfect. In data mining, we look for similarities, for patterns. We dig deep in the data in order to discover new knowledge, new information, how the data are linked together, how they are related to each other. So here we dig deep in the data. While big data is the whole data, the huge data. It's the bigger view of data. Okay? Keep in mind what we have said in several slides. The last 3 slides, I think. Big data, we compare it to the universe. So big data is looking to the huge amount of data in general, all the data. But when you go for this big data and try to look for, to explore, to mine for patterns, similarities, relationships, censoring, you are talking about mining. Okay? Why big data? Why big data is considered as an important issue nowadays? Because of business. People in business need to make decisions in order to improve their services, increase their revenue. So they need data. As we said, data-driven decisions. They need to have data, okay, in order to make decisions. And they make money out of that. So because of that, big data is very important. Is big data a hot topic? Yes, big data is a hot topic. Why? Because of many things. We have non-traditional data types, huge amount of non-traditional data types. We have big data volumes available nowadays. We have various data sources available. All these features currently available provide us with the huge data. And there are several other drivers to invest in big data. Technologies available, all the technologies you know nowadays, they also participate in increasing the size of big data. Economics, people in the different enterprises, they want to improve their services, improve their performance, right? Business insights. Okay? How to increase my customer loyalty? This is an issue for companies. They can make decisions in that if they can analyze the available data they have about their customers. Voila. Big data hype cycle. While I was looking for some new studies about big data and the status of big data, I end up with this figure. I don't know if any one of you see such figures before. Have you seen this figure? No. Huh? Anybody knows what this is about? Just tell me. This is the what we call hype cycle generated by Gartner. First of all, this figure, they have many hype cycle diagrams like this for different fields or topics. And this is for big data. What the figure is about, it says that at the beginning of any technology, any concept, at the beginning, you have some triggers that start that dimension or that track. Then people's expectations about this issue increase more and more till you reach the peak of expectations. You start having some companies working on the ideas, trying to produce new systems, use it, okay? People, companies, individuals, their expectation about that topic or domain becomes very high. Then once the community start using these systems, we will start having failures. Okay? Not everything started like that perfect. So we start seeing failures. Okay? Then we drop down, the expectations drop down. Okay? Till you reach the bottom here. After that, some companies, they are sustainable. They keep working on the ideas, on the system, see why they failed, how to improve. Then we start seeing the slope going up again till you reach the plateau of productivity where that concept, that system becomes mature and can be used. Okay? So this is actually a nice figure. I like it. Here, this figure is about the big data and the different concepts, technologies, techniques, tools related to big data and its use. Okay? What these small circles represent for each concept, Gartner, based on their studies and statistics, decided how long would it take for that concept or technique or technology, how long would it take for that concept from the start, from the trigger, till reaching the plateau of productivity or the maturity. Okay? And they classify it as less than 2 years, 2 to 5 years, 5 to 10 years, and more than 10 years. Okay? So the whole story started by having people start valuing the information. They start sense the need of information, the value of information. This one's the starting point. And then the whole techniques, concepts related to big data emerge. Okay? For example, this hype cycle for 2012. Every year, Gartner, they produce similar graphics. Okay? For example, maybe the text is not clear from your side, even from here, but I try to find, this is the clearer image I got. So, for example, you can see that text analysis, for example, it passes all that way. It has been implemented by different tools or techniques, reach the highest expectation from people and companies. Then the systems that make text analysis have been conducted or have been executed or tried by different companies with several failures. Then we come down. Now the text analysis is in this phase or in this location. And Gartner expects that text analysis in 2 to 5 years will reach the plateau of productivity. Semantic web. Semantic web started here after all these different concepts. For example, social analytics. What we have here that are very close to the plateau, we have, for example, predictive analysis, web analytics. It will take less than 2 years for them to become productive and mature. Okay? So we have different concepts, techniques that are related to big data, and this, based on Gartner statistics, shows when these concepts will become mature.
Can you name 2 or 3 in the leftmost?
There?
Down.
High performance. High performance computing, it will take 5 to 10 years to become productive and mature.
You mean it will go up, then it will go down again?
Because this is the nature. When you have some new technologies, people have big expectations for that technologies. But once you start having some systems that implement that concept, okay, and people, companies start to use it, they will be faced by several failures. Then the expectations go down. After that, some companies, not all of them, some companies, they keep working on these ideas, these systems, trying to improve them more and more. Then you will start seeing that the slope is going up again till you reach a stable level. Okay? Business intelligence, big data, data analytics, how they all fit together. As we have seen, business is the big driver for big data and analytics. Okay? So, for any business, they need to do different types of analysis, do several kinds of statistics in order to improve their competitive advantage in the market. They need to do, in the past, using old data. We conduct descriptive analysis. Descriptive analysis answers the question, what happened? When they are studying certain phenomena, what happened? Okay? This is what's covered by descriptive analysis. And this is based on old data. Diagnostic analysis, why did it happen? We try to find what are the different attributes, what are the different phenomena we have that are related to this topic we are studying, how they are related to each other, finding correlations between them. This is the diagnostic analysis. Then they do predictive analysis. Predictive analysis, okay? In order to predict, you use the data to predict what can happen, what will happen, okay? And you can also make predictive analysis. How can we make it happen? This is predictive analysis, okay? So part of the analysis based on something in the past Okay, and some of the analysis, we use the data in order to make predictions for the future. And in all cases, you need to use data. So big data is here. And the data analytics is used for predictive analysis. So in this context, big data and data analytics are part of the business intelligence. Okay, it's part of business intelligence. What examples we may have in such scenarios? Assume, for example, in Saudi Arabia, the Ministry of Health want to understand the coronavirus, for example. Okay? They need to conduct some descriptive analysis to understand what happened. Okay? They noticed that in some areas in the kingdom, there is a big number of people that have severe flu. I don't know what are the symptoms of corona. If they have flu, if they have fever, they start monitoring that by analyzing the data they currently have. So by the descriptive analysis, they know that there's something happened there. Okay? Then they try to study all the related information they have, for example, in the Ministry of Health, to know why they have these symptoms. Why the virus spread in that area. Okay? They study all the different attributes, a huge amount of data they have. For example, let's say that they have discovered that some kinds of vaccines, for example, haven't been taken by people related or in that area. So now they can find some relation between that vaccine and these symptoms. This is a kind of diagnostic analysis. Okay? Then they can make predictive analysis, what will happen. Okay, let's say, I don't know if corona, for example, spread a certain season or not. Let's say at certain season, corona or flu, for example, is more frequent than other seasons. So what can we expect in the next season? Where we'll have that flu? Where we'll have corona, for example? This is a kind of predictive analysis. And once you can predict that, you can decide what to do in that case for the next year. And this is prescriptive analysis. How to secure the different vaccines for these areas that are expected to have such virus or such problem. Assume that the ministry cannot provide the vaccine for all regions at the same time. So through the prescriptive analysis and the data they have from the predictive analysis, they can decide or prioritize the different areas from where to start. And this helps in managing the problem. Okay? Is it clear? Big data analytics tools, there are many tools used for big data. This is some statistics. This is a kind of survey that have been done online. The survey has the question, what analytics, big data mining, data science software you use in the past 12 months for a real project? The answers or the voters around 1,800. More than 18 or 1,900 people answered the questions. You have different tools here. The red ones are open source. I don't know why it is red. And the proprietary ones are green. Okay? You can see that RapidEye, RapidMiner, RapidAnalytics, these are the free editions. The free editions of these applications are used much more than the others. Are open source, also have been used. Excel, Weka, Pentaho, different tools that do data mining analytics. Now the challenges. We have three main challenges in data mining, in big data. The first challenge is related to the expression. How to express the big data. This is a big challenge. Okay? Since we already know that unstructured data takes over 70 to 80% of the digital universe, how can we express this unstructured data? How to express these unstructured data in an effective way that help in managing, analyzing, processing this data. This is a challenge. We need to do that in order to help companies deal with rapid growth of information. This is a key challenge in this issue. The other challenge is related to processing of big data. Nowadays, the data scale expands rapidly and exceeds the current processing capabilities of traditional computers. So, efficient processing of big data is also a challenge. How to process this huge amount of data efficiently. The third challenge is related to the reliability of the data. Now, due to the openness of the internet, big data management systems faces tests in the quality of the data input. When you use the available data, the big data currently available in order to make your analytics, how to judge the quality of the data that you use. How can you judge that the data you use is not fake? This is also a challenging issue. If you can see, according to Gartner's statistics, the key data is not correct or accurate in more than 25% of global Fortune 1000 companies. The top 1000 companies that uses big data to make decisions and do analytics, 25% of the data they use is inaccurate. So this is another issue. These are open issues, challenges. Controversy about big data. There is a big debate about different issues in big data. Some people say, why you call it big data analytics? It's data analytics. Data nowadays is big, and it will go bigger. So why differentiate? This is big data analytics or data analytics? No, it is data analytics. Big data may be a hit to sell Hadoop-based computing systems, where data management system sellers try to sell their systems, which are based on Hadoop, which is open source, to companies. This is also a controversial issue. Why using open source technologies to develop your own systems, then sell it to other companies? Some companies, big companies, this can be affordable for them if they can see benefits from that. But for SMEs, they cannot. For small and medium enterprises or entities, they cannot. It's not affordable for them. Although that systems are based on open source, on Hadoop, for example. In real-time analytics, data may be changing over time. So it's not important the size of the data you are using. The most important thing in real-time analytics is the recency of that data, whether it is updated or not. Bigger data are not always better data. If you go big, it doesn't mean that you will do the right things. It depends if the data is noisy or not, if it is representative of what you will study or not. So it's not always good choice to go as big as you can and take all the data available. These are issues that gain big debate in the academic communities and professionals. Other debates, claims to accuracy are misleading. When you take a huge amount of data, when you analyze big data, asking many questions or hypotheses, finding or using a huge amount of statistics, finding a lot of correlations between different attributes, it doesn't mean that you are doing things right. It doesn't mean that what you find is correct. It doesn't mean that. For example, Lew Weber, in one of his articles, he showed that S&P 500 stock index in one of the studies has been correlated with butter production in Bangladesh. How's that? They are not related. So, this is funny. So, having such a huge amount of big data, just making analysis, applying statistical techniques, finding correlations between many attributes is not always right. We have ethical issues. Ethical issues concerning the accessibility of data. Okay? The main issue is if it is ethical that people can be analyzed without they know that. And usually many companies do that nowadays. Another issue. Limited access to big data creates a new digital divide. So, companies that have access to big data, they can use the big data to do their analytics and make decisions based on that data and improve their situation, competitive advantage. But companies that don't have access to the big data, they will not. And this will make a big gap between the companies. New digital divide. Okay? Okay. What are the future trends in big data? We talked about the big data as a concept. We talked about the different challenges, the characteristics of big data. Now, in academia, in research, what are the new trends? What are the hot topics in research in big data? The first issue is related to the architectures used, the analytics architectures. Okay? What is the optimal architecture of an analytics system that should deal with historic data and with real data at the same time? We don't know. We don't have that optimal architecture for that analytics system. This is still in labs, research. Statistical significance. We already touched this issue. It's important to achieve significant statistical results and not be fooled by randomness or doing whatever statistics, just providing numbers. Distributed mining. Now, the different techniques, the data mining techniques that are used currently are not trivial to parallelize there. So how to parallelize the currently used techniques in data mining so they can handle the huge data or the big data, okay, to do analytics efficiently? This is also a big issue. Research trend. Time evolving data. Data may evolve over time, as we said. While you are conducting your analytics on big data right now, the data set that you are using is evolving during your analytics. So it's important that the big data mining techniques should be able to adapt and in some cases detect changes first. When you do the analytics, you want to be sure that you are using the updated data. Okay, don't rely on samples or the big data you have collected, for example, a few weeks or months ago. You want to be sure that when you conduct the analysis, you have the updated data. How to decide that? Visualization, also one of the research areas in big data. How to present, to visualize your results. It's very difficult to end user or to there are some missing characters here, but it's difficult to provide user-friendly interfaces that visualizes all the results of your analytics, which are based on big data. So visualization also is one of the new trends or research topics in big data. Hidden big data. Hidden big data is also an interesting trend. Large quantities of useful data are getting lost since new data are largely untapped. You have a huge amount of data nowadays are untapped. You know, we need tagging and searching and identifying the types of data. We need tagging. In 2012, IDC study on big data explains that in 2012, 23% of digital universe would be useful in big data if it is tagged, which means that 23% of that data is untapped. And they will be useful in data mining if they are tagged. Currently, only 3% of the potentially useful data is tagged. 3% of the data is tagged. And less of that number is actually analyzed. This means that big data is not a mature field. Still, it's in process. Gartner, in their hype cycle for 2003, what we have here, 2012. In their figure in 2003, they have expected that big data needs more than 5 years in 2013. Needs more than 5 years to become a mature field or to reach the plateau of productivity. So at least in 2018 or 20, it will become, it's still a mature field. Okay? Data science is multidisciplinary. Now, those who work on the data, those who have the curiosity to acquire, to get knowledge, to get data, okay? We call them data scientists, okay? And data scientist, or the field data science, is a multidisciplinary field that people who are involved in that, or the data scientists, should have skills in various fields. Data science, we have data mining, knowledge discovery, databases, visualization, statistics, pattern recognition, machine learning, AI. All these fields, all of them are mixed, okay, together and needed to become data scientists, or should be part of the data science as a discipline. By the way, data scientist is expected to be one of the hottest jobs in the coming years. Those who can read what's behind the data, they can understand the data, okay? They can find relations, predictions from the data. This is very important. So, what university research has had the biggest impact on you? During many, many decades, the research that has been conducted in the university and resulted in new technologies, new trends. Which one of them has the most impact on you? Is it the genetics revolution? Is it the Higgs-like particles that have been discovered in the universe and explains many things in the universe? Although this is important, but it doesn't touch you directly. Doubling life expectancy in last century. All these are very beautiful, good technologies, nice achievements for human beings, but they don't touch you directly. What touches you directly is the quantitative social science, which is known as big data, data analytics, data sciences. This will touch you directly and affects your life. Transformed most Fortune 500 firms. So the top companies nowadays in the market, that they have the most profit or value in the market, all of them resulted from social sciences. Twitter, Facebook, all these. Established new industries, altered friendship networks, increased human experience capacity, changed political campaigns, transformed public health, changed legal analysis. All these issues that touch you directly, they have been generated, produced, resulted from big data and big data analytics. This is an open issue about Megdam and big data. What are the opportunities, challenges, future of big data in Megdam Center? You may need to have like a brainstorming session with the professor to discuss these issues. These are some references that I used to collect these materials. And thank you.
Thank you very much, Dr.
You're welcome. Hopefully you had right now a good idea about the concepts of big data, what challenges, what trends, what are the characteristics of big data, what big data is about.
Are there any questions?
Any questions?
Just one question, actually. How different will be the techniques that are used currently now, for example, in data mining or in data analytics, would be different from those that should be used in big data analysis?
Well, in big data analytics, the techniques used nowadays, okay, as we said, we are not talking about data, big data analytics, it's data analytics. And in data analytics, you use what you currently have, okay, but you face some problems. As we said, this is research areas, open areas that needs more improvement. How to make these techniques suitable to manage the big data efficiently. Nowadays, many techniques can manage or can be used to analyze big data, but the point is efficiently. How you can make that efficiently, this is the point.
The issue is just scaling the current techniques to manage like a larger amount of information, but basically they...
Scaling, it's about the size, but sometimes it's not about the size. It's about the technique, it's the algorithms themselves. As we said, how to make the currently techniques used in data mining capable of making parallel processing or parallel analytics. It's a kind of algorithmic changes in order to cope with the huge amount of data. In the analytics, we use, for example, the decision trees, classifications, K-means, all these statistical methods, Bayesian methods, all of these methods are used in big data analytics. They are used in big data, and they are well known. They are not new.
I have a question. I think students might be very interested. You mentioned that data science is going to be the
this is one of the hot jobs in the near future.
Highest paid jobs. So
yes.
One might want to ask you, how do you become a data scientist?
Well, for example, EMC, they are providing exam. It's an exam that you have to take and become a data scientist. But in order to be able to take that exam, you should have a wide range of knowledge from different areas, as we said, in statistics, in data mining, in databases, in SQL, and all these issues. You have to be aware or understand these topics. And maybe in PSU, I think we need to restudy the course plan for students in order to provide them with these courses. For example, students should have course in statistics. I don't know, maybe they have one elective course or so. So those students who are interested to take the exam and become a data scientist, they should go with that path, taking course in statistics, database, relational databases, SQL, data mining, machine learning, all these stuff. You should have good knowledge of all these stuff. Then you can wrap them all together and then take the exam. It's not difficult exam. As I didn't take it, but as I've been told, it's not. It's a multiple choice, but you need to know all these issues.
So right now there's no major dedicated to data scientists in any of the universities.
No university can make a track for data science. It's not like a track, but different courses in the tracks we already have, you can take them because some of them electives. Mm-hmm. So if you are interested in becoming data scientist, you have to take these electives. Okay.
Any questions? Okay, thank you very much.
Thank you very much.
Yeah.
Thanks.